We now determine the total distance traveled by the particle in the first half second, given that the velocity function v equals 10t e power negative 2t. So we write down this total function. This is integral of the velocity function dt. Since we want to calculate the distance in the first half second, we put the limits as from 0 to off. That is, the lower limit is 0 and upper limit is off. Now let's substitute the velocity function. So therefore this integral becomes 0 to half. I am replacing v by 10t e raised to the power of negative 2t, and then we have this dt. So let's see how to evaluate this integral. First, I'm going to factor this constant out of the integral. I put this in front of the integral, so therefore this becomes 10 times of integral of 0 to 1 to 0 to half t e raised to the power of negative 2t dt. We now see that this is a product of two dissimilar uh, functions. This t is algebraic function, and this e raised to the power of negative 2t, this is an exponential function. So here we can use the integration by parts method. So we do this by integration by parts method, and in this method we follow the ILATE rule. This is shortly ILATE rule. Each letter stands for the functions. This I stands for inverse function, and this L represents a logarithmic function. A represents algebraic function. T is for trigonometry, and finally this E is for exponential. So we basically see the rule right from left to right. So when we see from left to right, the function comes as given in this expression, we choose that as u. So let's look out for inverse function. Do we have inverse function in this expression, that is in t e raised to the power of negative 2t? We don't have, because we have only algebraic as well as exponential. So we then move on to the next function in this order, that is logarithmic function. We don't have logarithmic function over here, so we ignore that. And once we move from logarithmic to algebraic, we have algebraic, so we can choose u as algebraic function. So therefore we choose u equal to t, and once we have chosen the u, the rest of the terms including the dt, we choose that as dv. So I'm going to write down dv, and this equals e raised to the power of negative 2t dt. So now we have chosen the u and dv according to this ILATE rule. Now let's see what we can do from here. So on this side, we have to take differentials. So differentials of u is du, and this equals dt. And on this side, we have to integrate. That is, integral of dv is v, and then we have to integrate this expression. So when we integrate this expression, this is e raised to the power of negative 2t, and then we have to divide by the derivative of negative 2t. The derivative of negative 2t is negative 2. So we put that here. We will not have to put the integration constant, because this basically is a definite integral. So now let's apply or evaluate this integral. So I'm going to write down the original integral, that is 10 times of 0 to half t times e raised to the power of negative 2t, and then dt. So we have considered this t as u, and then the remaining terms, that is e raised to the power of negative 2t, and this one as dv. And this means we can apply the integration by parts rule, that is integration of u dv, and this equals uv minus integral of v du. So it is according to this form. Therefore we can apply this integration by parts formula. So I'm going to do that. So since we have a 10, I put this 10, and then I am going to put a square bracket. Now I have to write down this u times of v. So u is t, I replace u by t, and then v is e raised to the power of negative 2t divided by negative 2. So I put e raised to the power of negative 2t divided by negative 2. And since this is a definite integral from 0 to half, we have to evaluate this expression from 0 to half minus, I put this negative, and then we have this integral from v du. So this is a definite integral, so I put this limits 0 to half, and then we put this v, that is e raised to the power of negative 2t divided by negative 2, and then du is dt. So we replace du by dt. Now let's close this square bracket. So let's continue. So this equals 10 times of, we will simplify this. This is, we can write down this as negative t e raised to the power of negative 2t, and this has to be evaluated from 0 to half minus, we have a minus over here, as plus we have a minus over here. So this will become plus integral of 0 to half e raised to the power of negative 2t and then dt. Let's simplify and evaluate this. So this equals 10 times of, we will now apply the lower upper limit and the lower limit by applying the fundamental theorem of calculus part 2. So according to that rule, we have to substitute the upper limit minus the lower limit. So when I substitute t equal to half, I get negative 1 by 2 e raised to the power of minus 2 times of, I replace t by half, and then minus, I put this bracket. We already have a minus, so this becomes minus of t is replaced by 0. So 0 times e raised to the power of minus 2 times of 0. So we have evaluated the first part, and then I put this plus. Now we have to integrate this e raised to the power of negative 2t, and this equals e raised to the power of negative 2t divided by the derivative of negative 2t, which is negative 2, and this has to be evaluated from 0 to half. So we close this bracket for 10. Now let's continue evaluating this. So this equals 10 times of, we have the square bracket. We see that this will get cancelled. That is e raised to the power of negative 1. So I can write down this as minus 1 by 2 times of e, because we will have e raised to the power of negative 1, and this equals 1 by e. So that's why I have put this as negative 1 times of 2 times of e, and this is 0 times of any number is 0, so we simply ignore that. And here we have this positive quantity as plus this negative quantity, so therefore this becomes negative 1 by 2 e raised to the power of negative 2t. This has to be evaluated from 0 to half. So let's evaluate the second integral by applying the limits. So therefore this becomes 10 times of negative 1 by 2e, and I put this negative 1 by 2. Now I applied the upper limit, so this becomes e raised to the power of negative 2 times of 1 by 2 minus, and I applied the lower limit, so it becomes e raised to the power of 2 times of t is replaced as 0. So let's close this, and this equals 10 times of negative 1 by 2e. This is negative 1 by 2, and this will get cancelled. So e raised to the power of negative 1, I can write down this as 1 by e minus, and this becomes 2 times of 0 is 0, and e power 0 is 1. So I simply put this as 1. Let's simplify. So this equals 10 times of minus 1 by 2e. We now distribute this 1 by 2 into the two terms inside the bracket. So this becomes minus 1 by 2 times of e, and this negative times negative is positive, so it becomes positive 1 by 2. Now I can combine these two like terms. That is, this is basically 2 times of, because we have this term, the same term we have, and we have to add in terms of negative signs. So it is basically, we can write down this as 2 times of negative 1 by 2e. So these two and this 2 gets cancelled. So therefore this equals 10 times of negative 1 by e plus 1 by 2. We now evaluate this expression inside this brackets. and then multiply with 10. And when we do that, we get the approximate value as 0.6606. Okay, it looks like I've done some mistake in the beginning. When you look at this expression and this expression, I did not put this negative half. So we have a negative half here and we have a positive half here. So we can factor the 1 by 2. So therefore this quantity we can see this is 10 times of 1 by 2 and this equals 5. So that's the thing that we need to correct. So therefore all these constants will become 5. So they all becomes 5. This is also 5 and all this should become 5. This 5, this 5, this is also 5 and this is also 5. So we get this expression. This is the approximate value. And if you want only the exact distance, you can write down in terms of the expression. That is, we have to simplify 5 times of negative 1 by e plus 1 by 2. We can simplify this. So this equals 5 times of negative 2 plus e divided by 2e, or in fact if we distribute the 5 into the two terms inside the bracket, we get I put this 5e first minus 10 divided by 2e. So we can see that this is the exact distance traveled by the particle in the first half second. First half second, and this is in meters. If you need the approximate value, this is the one 0.6606 and this is in meters.